Assalamu alaikum guys, welcome to my channel Electronic Devices Analysis. So guys, our today's topic is common base configuration. As we know that there are three types of configurations of bipolar junction transistor: common base, common collector and common emitter configuration. But in this video we will discuss only common base configuration in detail. So guys, before I start a video, please subscribe our channel and press on bell icon for more informative videos which I will upload in future. So guys, let's start. Guys, first of all we see the circuit of common base configuration. In this circuit you will see that the base terminal of the transistor is grounded, therefore it will be a common base configuration. To analyze any circuit you first have to see that the transistor is work or not. A transistor is work if its base emitter junction is forward biased, as we already see that base emitter junction must be forward biased and collector base junction must be reverse biased. So it is the base emitter junction, this one will be the base terminal, this one will be the emitter terminal. So this junction is base emitter junction, this one in n side which is connected with negative, p side connected with positive, so it will be a forward bias condition. This is an npn transistor because arrow node point is bars, so therefore it will be a npn transistor, and base emitter junction is forward bias, so first condition will be fulfilled, and then collector base junction must be reverse bias. So there you can see that the collector base junction is reverse bias because positive is connected with negative and negative is connected with positive, so it will be a reverse bias condition, so our transistor will work. So guys, now I analyze it. To analyze any circuit you have to see its two loops, the input loop and the output loop. In input loop always base emitter junction is present, but in output loop always collector base junction must be present. To analyze any configuration more efficiently, first we have to draw its input characteristics and its output characteristics. Its input characteristics are drawn between IE and VBE because in input loop there is a current only IE is flowing, because IB is grounded, so will not taken it, IE is flowing, so the graph will be IE versus VBE because there is a junction present VBE. Of collector based junction is not present in it, so for every value of VCB one line will be drawn on the graph. But in output loop you will see that there is a current IC, so the graph will be drawn between IC versus and the junction will be VCB for every value, for every constant value of IB. Will not take VBE because VBE is fixed at 0.7 volts. As we know that this is a forward bias diode, so it will be fixed at 0.7 volts. We will not take it, we will take IB. So guys, first of all we draw its input characteristics. Here we will plot the input characteristics of common base configuration, which are drawn between IE versus VBE. VBE is on x-axis and IE is on y-axis. For every value of VCB, one line will be shown on the graph. As we know that the base emitter junction is forward bias. As we know that in input loop base emitter junction is forward bias, so it will be work like a diode. And you know that the diode characteristics are this type of characteristics because at 0.7 volt no current is flowing, and after 0.7 volt a high amount of current is flowing. For every value of VCB, so it is VCB, let's say, is equals to 0, this is VCB is equals to 1. As the VCB will be increases, this graph will be tends towards IE, because as collector base junction is reverse bias, so it will behave as an open circuit, so high depletion region, high open circuit, and so all the voltage will be drop over there, so therefore IE will be small, so therefore these lines are tends towards IE. So guys, these are the input characteristics of common base configuration. Now we will see the output characteristics of common base configuration. Now we will see the output characteristics of common base configuration. As we know that the output characteristics of common base configuration is drawn between IC and VCB. VCB is on x-axis and IC is on y-axis, and for every value of IB, one line will be plotted on the graph. As we know that the base current IB is in microamperes, which is too small current, but IC and IE are in milliamperes. As we know that the VCB will be increases on the x-axis, so the high open circuit will be taken. As the VCB is equals to 0, so there is a high amount of current IB will be flowing, which is approximately 50 microamperes. We suppose it 50 microamperes. As the VCB will be increases, the IC will be decreases, IB will be decreases. So until the VCB is more increases, so IB will be tends towards the x-axis and in the zero line. This is 40, this is 30 microamperes, and this will be a 20 microamperes, and then towards the zero. So these are the output characteristics of common base configuration. As the VCB will be increases, the IB will be decreases. There is a saturation point and there will be a cutoff point. We will plot them over here. It will be a cut over a baseline, which is called the Q point of a transistor. We will not know what is the saturation region, we will not know what is the cutoff region. In next video we will see what is the saturation region and what will be a cutoff region. So guys, that's it from the output characteristics of common base configuration. Now we will move forward to the main circuit of a transistor of common base configuration. We will back on our previous circuit of common base configuration. We will draw some formulas of common base configuration over here. In this circuit you will see the input KVL loop and output KVL loop. Only we will discuss over there that VEE will be drop over IRE, which is called IE into RE, plus this junction will be taken. This is base emitter junction, which will be a 0.7 volts. Its negative is connected with negative and positive is connected with the positive. So here we only write 0.7 volts. This will be the input KVL loop of common base configuration. In output loop you will see that VCC will be drop over only this resistance. This will be IC into RC. So there is no need to find this loop. We will only find this current IC is equals to beta times IB. As we know that the beta is equal to IC over IB, so IB will be over here. So IC will be taken from this formula because beta of every transistor will be given. So we will find IC, we will find VC from IC into RC. So voltage VC will be taken, voltage VE will be taken. So that's all. These are all formulas we will take from common base configuration. So guys, if you like our video, press on like button. That's all for today. Allah Hafiz.